Ionic compounds. We know that ions is an atom that has a positive or negative charge. So ionic compounds are compounds that involve ions. We know that the only particle that can be gained or lost when forming ions are the electrons. Cations is a name for a type of ion which is a positively charged ion. And the way a positively charged ion can exist is if it loses electrons. An anion is a negatively charged ion, and the way it can exist is by gaining electrons. On the periodic table, here are some trends. Okay, +1 charge in this column, the alkali metals. +2, the alkali earth metals. Transition metals form various cations with various charges, but we'll talk about those later. The aluminum family makes a +3 charge. The nitrogen family makes a -3. Oxygen family, -2. The halogen family, -1. And these guys right here, the noble gases, make a 0 charge when forming ions. Now notice there's a pattern here. Metals form cations, non-metals form anions. The formation of ionic compounds is very simple. They usually involve a cation and an anion, usually a metal and a non-metal. But here's the caveat here. A compound must have a net charge equal to be 0 in order to be stable. Here's an example of that. We have Na plus and Cl minus. Notice how when we write the compound, the cation always goes first. When we balance the charge, we have one cation of +1, one anion, which is -1, +1 minus 1 equals 0. Here's another example. Mg2 plus Cl minus. Okay, notice the 2 right here. This means something. So let's take a look at what it means. We need one cation of a 2 plus, but we need 2 anions of a -1 charge to balance out this 2 plus. So this 2 is represented by this little subscript, this little 2 right here. And that's how we write it. This 2 in back of any element represents how many we need. So +2 minus 2 equals 0. One more example. We need 3 lithium pluses plus 1 nitride ion of a 3 minus. And again, this 3 is represented right here as a little subscript to balance out the charge. So we need 3 plus 1s plus 1, -3, plus 3 minus 3 equals 0. So here's kind of like a picture example of what we're doing here. Mg +2, well, that means that we have 2 pluses, and oxygen has 2 minuses, and we add them together, +2 minus 2, 1 Mg, 1 oxygen, equals 0. So we write the compound MgO. Here's another example. SN4 plus, P3 minus. So that represents 1 SN plus 4 ion. And this represents 1 P3 minus ion. And if we add them together, notice how they don't match and they don't equal 0. So we're going to have to add more. So we're going to add another P, another SN, another P, another SN, and another P. So this represents 1 SN, 2 SNs, 3 SNs. This represents 1P, 2P, 3P, 4P. So how do we write the compound? SN3P4. There's another way we can do this, and it's called the chargey-switchy shortcut, where we take the charge of one atom and we make it the subscript of another. And we take the charge of the other and we make it the subscript of the other. Okay? Now again, this only works about 95% of the time. So be cautious. Be cautious. It only works when charges you have an uneven charge and an even charge.